Welcome back to Science Modernizers. In today's video, we are going to see a question of rotational dynamics, that's moment of inertia, further mathematics, paper 3, that's June 2018, question 8. The question reads, a cylindrical pulley of mass 2m and radius r is free to rotate about its axis, which is horizontal. A light inextensible string hangs over the pulley and carries a particle p of mass 2m at one end and a particle q of mass m at the other end. The system is released from rest when the string is taut and the hanging parts are vertical. Show that the acceleration of P is 1/4 g 9 marks. Find the tension in the string on either side of the pulley 4 marks. Find also the vertical force exerted by the string on the pulley 2 marks. Okay, so let's draw the equivalent diagram to represent the system. So let's draw a pulley. That's a pulley. Now on the next, we attach our ropes. Okay, so now on this, we are going to attach our masses. So here I have mass P, which has a mass of 2m, and here I have mass Q, which has a mass of m. So definitely the radius of our pulley is r and the mass is 2m. So resolving, here we have 2mg as the weight of P and the weight of Q will be mg. So here we are going to have our tensions. Here we have T1 and on this side I will have T2. Now this means the reaction force will be vertically upward, so I'm going to call it R. Now before we start, we have to define our direction of angular acceleration, and I will consider the clockwise direction to be positive. So that's what we get. So then the first thing is to show that the acceleration of P is 1/4 g. Now considering our system of masses, where we have Q and we have P. On P we have a weight of 2mg and we have the tension force T1, and here we have a weight of mg and we have a tension force of T2. So if we resolve each of the system separately, that's applying Newton's law, and since the two masses are linked together with the same string, it means they are going to have a common acceleration. So from Newton's second law, the sum or the resultant of all the external forces should be equal to MA. Now this means that we have, since my direction of acceleration is downwards, that's positive in this convention, it means 2mg will be greater. So for system 1, I will have 2mg minus T1 is equal to 2ma. I will call this equation 1. Then for the second mass, I will have, since my acceleration is in the clockwise direction, it means T2 will be greater than mg. So I will have T2 minus mg will be equal to the mass m times a. So I will call this equation 2. Now here we have the acceleration which is unknown, we have T1 and T2 which is unknown. So we will be unable to solve these two equations with those two unknowns. Now we have to get another equation that will permit us to solve this particular problem. And so what we are going to do is, we are going to use the fact that the sum that's from Newton's second law for rotating bodies. What do we have? That the sum of the external torque should be equal to I times theta dot dot. In other books you will see them as I alpha or J theta dot dot. It's the same thing, where I there is the moment of inertia of our pulley and theta dot dot is the angular acceleration. So what we have From there, one can have that the sum of the external torque. What's the external torque? The external torque will be due to this couple, these tensional forces. So if I look at my string and my pulley is rotating in the clockwise direction, so that will be due to this tensional force at T1. So definitely the rotational torque will be given by T1 times the force times the perpendicular distance. So the force which causes the rotation times the perpendicular distance from this axis of rotation, which is the center. And so we see here that the force is T1 and the perpendicular distance will be R. So, and it is in the direction of my consideration, so it is clockwise, so it will be positive. So it means I will have T1 times R. Now let's verify T2. So T2 is going to counteract the turning effect of my positive convention. So the torque there will be negative. So I'm going to have minus T2 R will be equal to I theta dot dot. But what do we know? The moment of inertia. But the moment of inertia of our cylindrical pulley is mr squared divided by 2, where m is the mass of the pulley, r is the radius, and we divide by 2. So the mass of our pulley was given to be 2m times the radius, which is r, all of that squared divided by 2, which is simply mr squared. And so we have here we have the angular acceleration theta dot dot, but the relationship between the linear acceleration and the angular acceleration is that our linear acceleration is always given by theta dot dot times r, and so this means that our theta dot dot will simply be the acceleration divided by the radius. So I will replace in the equation of the torques. So this means I will have T1R minus T2R to be equal to the moment of inertia, which is mr squared, all of this times a on r. Now we see that these r's we cancel out, one of these and one of these we cancel, and this r we cancel with the rest. So finally we are going to have T1 minus T2 to be equal to me. I will call this equation number 3. Now from our first two equations, from equation 1 and equation 2, we can get another equation in terms of T1 and T2s likewise on this side. Now but we are looking for the acceleration, so we have to eliminate tensions at all costs. So since we have an equation in terms of the tensions and we have two equations in terms of tension, what we are interested in is we are looking for the acceleration. So if from here, from this degree, from equation 3, I'm going to make T2 the subject. This means T2 will be equal to MA, now will be equal to T1 minus MA. So I'm going to replace in equation 1, or is it equation 2? So we are going to replace T2 in equation 2. So replacing it here, we are going to have T1 minus MA now minus mg, that be minus mg will be equal to MA. So if we rearrange, we are going to have T1 minus mg is equal to 2ma. I will call that equation star, and I will solve it simultaneously with equation 1. Equation 1 is 2mg minus T1 is equal to 2ma. So here we have 2ma. That was my equation 1. Now with these two equations, if I want to eliminate T1, all I have to do is I'm going to add both equations. So if I add both equations, T1 plus negative T1 we cancel, I will have negative mg plus 2mg will simply give mg, which will be equal to 2ma plus 2ma, which is 4ma. So the a's we cancel, and so from here we see that the acceleration A will be g divided by 4. So therefore the acceleration of P will simply be 1/4 g as required. Okay, so the first part, which is 9 marks, is done. Now the next is find the tension in the string on either side of the pulley. So we have to find T1 and T2. Now from 1, that's number 2. So we are looking for T1 and T2. Now from 1, what do we get? We have that 2mg minus T1 is equal to 2ma. So we have 2mg minus T1 is equal to 2ma. So this means T1 will be equal to 2mg minus 2ma. But we already know the value of A. So T1 will be equal to 2mg minus 2m. But our A is g on 4. So this cancels with this. So this will give 2mg minus mg on 2. And so this will give 3mg on 2. So therefore T1 is equal to 3mg on 2. Now doing same for at the level of equation 2, we get that T2 will be ma plus mg. Similarly in 2, we have that T2 will be equal to ma plus mg, which is mg divided by 4 plus mg, which is equal to 5 all over 4 mg. So those are the respective tensions. Now the last one says find also the vertical force exerted by the string on the pulley. So the vertical force is our reaction force. So the reaction force will simply be equal to the sum of our two tensions. So R on the pulley, we have a system like this. So we have our tension force. We have one this way, and we have another acting this way. Okay, so now here we have our reaction R. So here we have T1, here we have T2. So the reaction will simply be T1 plus T2, and our T1 was 3mg on 2, 3mg divided by 2 plus T2, which is 5mg on 4. And so this is the same as 6mg on 4 plus 5mg on 4, which is going to give 11mg on 4. So that is the reaction force R. So this brings us to the end of this video. Please do not forget to like, share, subscribe, and drop your questions in the comment section. See you in the next video.